Now, in order to solve this equation, 12 cos x minus 4 sin x equals 7, we draw on the last part. We know that the left-hand side here can be re-expressed as r cos x plus alpha, which we worked out. We worked out in the last part that r was 4 root 10. Let's just write that in, 4 root 10. Then it would be cos of x plus alpha. And alpha was 18.4349 and so on. Try not to use the rounded version because you possibly could carry through rounding errors. Okay, so that's an unrounded version, and then that equals 7. So to do this now, we need to get rid of the 4 root 10, or you might have that as the root of 160, but we need to divide both sides by that value, and that gives us the cosine of x plus the 18.4349 and so on degree angle equals 7 divided by 4 root 10. So to get the x plus 18.4349 odd degrees, we need to take the inverse cosine of both sides. So if we do that, we're left with x plus 18.4349 and so on equals the inverse cos then of 7 over 4 root 10. And what do you get if you do that? Well, you should find that your answer comes out at 56.3995 and so on degrees. Now, it's very tempting to take away 18.4349 now and get a new answer and then go on to draw, say, a graph or a quadrant diagram. Don't do that, okay? What you need to do, say if you're using the quadrant diagram or graph, is to draw it now. Well, I'm going to draw the quadrant diagram, and I'm assuming you're familiar with this. If not, just again look on my website and you'll see tutorials on this. But this will be 0 degrees, and we're looking for where cosine is positive, and cosine is positive in the first quadrant and the fourth quadrant. So I'd mark 2 lines equally inclined to the horizontal here, and this will be 0 degrees. I'd mark those in as being the same angle. And what we want is angles between solutions between 0 and 360 degrees. So we need to start from here, and the first solution would be round to this first blue line, and this is a possible x plus 18.4349 degrees. We should also start from here again and turn round in an anti-clockwise direction to the next blue line. So these are going to be our 2 solutions, and we've already seen that when we inverse cos this value, we end up with 56.3995 and so on degrees. So that means one of these blue angles in here is 56 degrees. I'll just leave off this last bit, although I'll remember that's in there. So there we go. Let's just mark that in there, that is 56 degrees. So to get that red one, which is what we've got here, there it is, okay, 56 odd degrees. Now we need the green one, and to get the green one, all we need to do is 360 degrees minus the 56.3995 degrees. So put a comma there, and if you do that, you'll find you get 303.6004 and so on degrees. Now take your 18.4349 degrees from each of these, and that will leave you with your x. So if you do it from the first one, you'll get 37.9645 and so on degrees, and if you take your 18.4349 away from this one, you'll get 285.1655 and so on degrees. And we've got to give our answers for x to 1 decimal place, so the first one's going to be 38.0 degrees to 1 dp, and the second one is going to be 285 0.2 degrees. Okay, and that's to 1 dp. So I hope that's given you some idea how to do that, but as I say, don't make the common mistake of working out this angle, taking away 18.4349 degrees from it, getting 37.9 odd degrees, and then marking that in on your quadrant diagram, and eventually doing 360 minus the 37.9645. You'll get it wrong. Okay? So, well, that brings us to the end of this part anyway of the question.